So what we're going to be looking at today is percentage error, and this is something we looked at right back in the beginning of year 11. And so just to review it, percentage error is any measurement any measurement that has an accuracy of plus or minus a half of the smallest unit on the scale of the measuring device. So that means if you had a meter ruler and your meter ruler could only measure in meters, then the accuracy would be plus or minus half of 1 meter, which would be plus or minus half a meter. Now this is sometimes called the absolute error. Sometimes you might see it as a relative error. Sometimes you might see it as a maximum error. All of these words are percentage or errors. And so at this point in time, we're just looking at error. The percentage error is the absolute error divided by whatever the measurement is, whatever you measure something to be, and times it by 100. The smaller the percentage error, the more accurate the measurement. So the percentage error, and this is one thing that does not appear on your formula sheet, something you have to learn. Percentage error is the absolute error, or the maximum possible error, over the measurement times by, and this really should have a percentage sign after it, and we all know that we don't actually do the percentage on our calculator, but we do need to realize that there is a percentage sign there. So let's have a look at how we can go about doing this. So, for example, the length of a basketball court is measured as 26 meters, and it's being measured to the nearest meter. And it says the amount of petrol pumped into a car is recorded as 35.8 litres. And it's saying for each measurement, calculate the range of possible values of the measurement and the percentage error correct to two significant figures, I should say. So let's have a look at, first of all, the basketball court first. So that's the first thing, the basketball court. Okay, so let's have a look at, it says the range of possible values of the measurement. The first thing you have to work out is the absolute value, or the absolute error. So absolute error. And what we're going to be looking at, that's plus or minus a half, and I'll just write that as 0.5, but I could have just written that as a half, of the smallest unit. Now the smallest unit of the basketball court, the level of accuracy was 1 meter. So it's plus or minus a half of 1 meter. And plus or minus a half of 1 meter is really just plus or minus a half, which is 0.5. Now that's the absolute error. Now what we need to do is we need to find the range of values. I'm not sure why my computer keeps making things disappear. So the range of values, can you see we've got 26 meters? So 26 meters is the actual value that we're starting with. And we're doing plus or minus half a meter on either side. So if I did 26 minus half a meter, I'm going to get 25.5, which is the lowest value I can possibly have. And we're going to look now at the highest value I can have. 26 meters plus half a meter is going to be 26.5 meters. And that's as far as we need to go. Let's have a look at the next part then, for petrol. Let's see what happens for petrol. Perhaps I should change colours so make it a bit easy to see. So for petrol, we need to find that absolute error as well. So let's have a look at finding that absolute error. And if you can see, this is measured to the nearest 0.1 because we've got 0.8. So it's plus or minus a half of, and the lowest measurement, or the most accurate thing, is 0.1. And now if we do, you can ignore those plus or minuses at the front, 0.5 times 0.1, what you get is 0.05. And having a look then at the next part, we need to find the range of values. And so that range of values is going to be, we've got 35.8, because that's how much petrol we put in our car, and it's plus or minus now 0.05. So if we have a look at that, why does this keep disappearing? So we've got, work that out on our calculator, 35.8 minus 0.5, that's 35.75. And the highest value is going to be 35.85 litres. So that's the first part done. Now we need to find the percentage error. And to do that, it's really quite simple. For our basketball court, and I'll just do it over here on the side. In fact, you probably won't see it, so I'll just do it down here. For a basketball court, the percentage error, and we're just going to use that formula, is plus or minus a half, because that was our absolute error, over the actual measurement we had, which was in this case was 26, and we times it by 100%. And you can ignore this, don't need the percentage sign in your calculator. You're just going to go 0.5 divided by 26 times 100, and the answer you get, and it's going to be plus or minus, it's 1.9%. That's what the percentage error is. Now if we do exactly the same for the petrol, we have a look at the absolute value. The absolute value is 0.05 over the measurement we had, which in this case was 35.8, and we're going to multiply that by 100%, and we're going to go back and remember it's plus or minus, and if we put that in our calculator, what we end up with is plus or minus 0.14%. And the last question, part B, says which measurement is more accurate? Well, the one that is more accurate is the one that has the smallest value. So the petrol is the answer to that question. So which one's more accurate? The petrol. There's less error in there. Okay, let's have a look at the very last question. A car's fuel tank has a capacity of 65 litres. If this capacity is given to the nearest litre, so our measurements are in the nearest litre, find the degree of accuracy as a percentage correct to 2 decimal places. So all you have to do then is you need to find that absolute error. Let's write that down, absolute error. And it's plus or minus a half of the smallest unit. And if we have a look at it, it has a capacity of 65 litres and it was given to the nearest litre. So that's times by 1 litre. So it's just plus or minus a half. And now we need to find that percentage error, because that's what the question's asking us. So that's plus or minus a half over what we've actually measured, which we have is 65. And we're going to times that by 100%. And we'll pop that in our calculators and we're going to get 0.77%. And we're not going to forget that plus or minus that lives on the front. And that's all there is for percentage error. Hope you all remember this. Any questions, you know where to find me.